look at cofunctions. I think one of the big keys with cofunctions is kind of understanding that co in front. So the relationship that we're dealing with cofunctions is easy to see when we take a look at a triangle and we look at all the different sides and angles of a right triangle. Now, specifically, we're dealing with right triangle trig, so we do need that right angle in our diagram. We need to know the lengths of the sides. So in this case, we know it's a 5, 12, 13 right triangle. I know one angle is 23. And the one cool thing about those right triangle angles is the two non-right angles are complementary. And again, that's kind of what's going on with this word complementary. Now, if you guys remember, complementary means adds to 90, right? These angles add up to 90. So that means this missing angle and 23 have to add up to 90. So if I take 23 away from that 90-degree angle, I end up with a 67-degree angle. Now, here's the cool part of this. If I look at the sine of the 67-degree angle, the sine of the 67-degree angle, for the 67, the 12 is our opposite side, over 13. Now, if I look at the cosine of the 23-degree angle, that's our adjacent over our hypotenuse. So for the 23-degree angle, the 12 is now the adjacent, and 13 is still our hypotenuse. We actually get the same answer, and that's not by coincidence. When we're dealing with complementary angles, angles that add up to 90 degrees, their sine and cosine are going to be equal to each other. Now, I could do the same thing with I'm going to slide this over a little bit here. I could do the same thing with the sine of the 23-degree angle. The sine of the 23-degree angle would be the opposite, 5 over 13. And then I could do the cosine of its complement, right? The other angle here, cosine of 67 degrees. Cosine of 67 would be the adjacent, which in this case is 5 over 13 also. So if you notice, when we're dealing with sine and cosine, as if their angles add up to 90 degrees, their sine and their cosine are going to be the same. So this is what we call co-functions, right? They're complementary functions. So again, if those angles add up to 90 degrees, their sine and cosine will have that same ratio. Super cool relationship here. So what we want to do is kind of put this into a little bit of a mathematical equation. We know that the sine of one angle is equal to the cosine of the complement. Cosine of one angle is equal to the sine of its complement. As long as those two angles add up to 90 degrees, we're good to go. Now, one thing I kind of want to point out here is if you think about the words sine, which fully spelled out as S-I-N-E, and cosine, literally the only difference between these words is the co up front. And remember that co is going to stand for complementary. So those angles need to be complements of one another. They need to add up to 90 degrees. All right, so let's take a look at a couple quick examples here. One is sometimes you guys will just be given a mathematical equation saying the sine of one angle equals the cosine of another. How do we find theta? Now, since we know that these are co-functions, what we know is these angles, for these to be equal, the angles have to add up to 90 degrees. They have to be complements. So 30 plus some angle theta has to equal 90. Subtract the 30 and we end up with theta equals 60 degrees. All right, so again, setting these equations equal to each other, we know sine and cosine are equal to each other when the angles, right, so 3x plus 10 and x plus 24 are complementary, meaning they add up to 90. So we could do 3x plus 10 plus x plus 24, that equals our 90 degrees. And we'll solve for our x. So we end up with 4x plus 34 is equal to 90. We'll subtract that 34 from both sides, right? So minus 34. We end up with 4x is equal to 56. And then when we divide by 4, we end up x is equal to 14. And so our value of x would be 14 degrees. Another way for them to describe this is talking about like a right triangle. So in right triangle ABC, so we have some type of right triangle. We don't know exactly what it looks like, ABC. We know that the measure of angle C is 90, so this is our angle C. and then AB would make the other two. Now, since we're dealing with a right triangle, I already know that angle A and angle B are complements. Angle A plus angle B are going to have to add up to 90 degrees. So that means the sine of angle A is equal to the cosine of angle B, or the sine of angle B is equal to the cosine of angle A. So they're giving us the cosine of angle A. So we know the cosine of angle A is going to have to equal the sine of angle B. So since the cosine of angle A is 1/5, right, the cosine of angle A is 1/5, that means the sine of angle B is also going to have to be 1/5. So our answer would be 1/5. All right, so there's some practice questions on the back of this. Take a look. If you still need more help, we'll continue with a little extra practice to make sure that we can hammer this one home.